In this example, we're going to do an integral that requires the method of partial fractions, and we're also going to introduce a common trick that's used when doing partial fractions. The basic idea is that we have a complicated fraction, and we're going to turn it into a sum of simple fractions that we can actually integrate. So here we have the integral of x plus 7 over x squared plus 9x plus 20. And the first thing that I'm going to want to do is try to figure out how to factor this denominator. In this case, it's pretty easy because I just need to think of two numbers that multiply to 20 and add a 9. And those numbers are 4 and 5. Those multiply to 20 and they add to 9. The next thing that I want to do is the actual partial fractions aspect of this problem. I'm going to split it up. I'm going to split up this fraction into two fractions. The sum of a over x plus 4 and b over x plus 5. Right now, these a and b's are placeholders for numbers that we don't know, and so they're called undetermined coefficients. In order to figure out what those coefficients are, we're going to need to recombine this into a single fraction. So after I recombine it into a single fraction, I had to multiply the first term by x plus 5, since it was missing x plus 5 from the denominator. And I had to multiply the second term by an x plus 4, because it was missing x plus 4 from its denominator. The next step is what's called clearing fractions. If this fraction on the left is equal to this fraction on the right, then their numerators have to be equal since they have the same denominator. So we're just going to set these numerators equal to each other, giving us x plus 7 equals a times the quantity x plus 5 plus b times the quantity x plus 4. Now, first I'm going to show you the normal way that you can solve this, solve for the values of a and b, and then I'll show you the trick afterwards. So the normal approach involves just expanding the expression that's on the right, collecting all the common terms, the like terms I should say. So for example, if we collect the terms that are proportional to x, we had an a times x plus a b times x. So we get a plus b times x. And the constant terms end up being a times 5 plus 4 times b. Now what we can do is, since these two equations are equal to each other, their coefficients must be equal to each other. The coefficient of x has to be equal on both sides, and also these constant terms need to be equal on both sides. This leads to a system of equations. The first equation says that a plus b has to equal 1, and the second equation says 5a plus 4b has to equal 7. And the normal way would be to solve this system of equations. Since there are only two equations and two unknowns here, that could be done pretty quickly actually. Like you could subtract 4 times the first equation from the second equation to figure out the value of a. However, there's a trick that makes it even easier to solve this, solve for the values of a and b in this problem. So I'm going to show you the trick instead. The trick is that this equation needs to be satisfied for any value of x. And so if I choose my value of x appropriately, I can eliminate terms from this equation. For example, if I let x equal negative 4, then this term involving b is just going to disappear, and I can immediately solve for a. So let's do that. Let's let x equal 4, negative 4 and 7, add the 3, and negative 4 and 5 add the 1. And like I said, this term just disappeared. So we have already figured out the value of a. It must equal 3. We're going to figure out the value of b in a similar way, but now we want to kill the term that has x plus 5 in it. So we're going to let x equal -5. Once we let x equal -5, we get -5 plus 7 gives 2. This term disappeared, and b times -5 plus 4 means we have b times -1. Thus, we get that b is -2. And now we have the values of a and b, which was the thing that we were trying to figure out. So we can now rewrite this fraction that we started with as a sum of these two simpler fractions, where we actually know these constant terms now. So let's do that. A was 3, b was -2. And so we can write our original fraction as 3 over x plus 4 minus, due to the -2, 2 over x plus 5. These two simpler fractions are ones that we can almost immediately integrate, and that's what we'll do. So we're now going to integrate 3 over x plus 4 minus 2 over x plus 5. We do that term by term, and we end up with 3 times the natural log of x plus 4 minus 2 times the natural log of x plus 5. Implicitly, we're using u substitution to go from this line to this next line. Like we used u equals x plus 4 to get here, and the integral of 1 over u is the natural log of u. Similar for the second term. We let u be x plus 5, and we got the natural log of x plus 5. Right. So this shows how to use the method of partial fractions to integrate. There are some variations on this idea that we'll explore in the next videos.